Good morning, friends, and welcome to another class. In today's episode, we will be looking at valuation of solutions. So, I believe we can start. Now, before we start, we need to first understand the meaning of the word dilution. And I would use this illustration to explain the term dilution. Let's assume that you have a container, this container, and within this container, you have salt solution, salt water. Now you realize that this salt water is so concentrated, so you decided that you'd add some more water to it because there is too much salt in the salt water. So you wanted to reduce the salt content. Normally, what you'd be doing is you would add water to it in order to reduce the salt content. So you added a lot of water, you got this. So this has more water. Remember, you first need to remember that the quantity of salt you did not change. You only added water to it in order to reduce the concentration of the salt. That was what you did. So let's look at a few things that would happen when we add water to this salt. That's salt one, salt water one. I'll call this salt water two. So you see what happened. That's the concentration. I'll call the concentration of salt water one concentration one and the volume of the salt water one concentration volume 2 1. Again for salt water 2, I'll call it concentration 2 volume 2. Now the question is this: did the concentration of the salt water change after you added water to it? The answer is yes. You realize that in the first salt water, when you tasted it, there will be more salt. But when you taste the second salt water, there will be less salt. When you again look at the volume, you realize that the first salt water will have less water compared to the second salt water. Now, the addition of the water to the initial salt water to get the second salt water is what we call dilution. In fact, dilution, whenever you dilute a solution, what you are simply doing is you are adding more water to that solution in order to decrease the concentration. And usually that results in producing a higher volume because you are adding more water. You end up producing another solution that has a lower concentration but has more volume. So it's also one of the things you need to know about dilution can do solutions. Now, let's also think about something else. So we know about concentration, how it's being affected by dilution. We also know about volume, how volume is affected by dilution. What about the mole? I'll use a different color for this. What about the mole? So let's call mole 1 for the and this one mole 2. Mole, remember, is the amount of substance, chemical, or in anything. Yes, that's what mole is. So the question is, did the mole also change? Now remember that the mole depends on the quantity of maybe the chemical, in this case sodium chloride that was placed in the solution. But you realize that all we did was we added water to the first solution to get the second solution. We didn't add any sodium chloride. So because we did not add any sodium chloride, what it means that the mole or the amount of the sodium chloride will not change. So in the first solution, and the second solution, then amount of sodium chloride should be the same. The only thing you did was to add water in order to dilute the first solution. But the number or the quantity or the amount of the sodium chloride in the solution, it didn't change. So it will be the same in solution 1 and solution 2. Now this formula, let me write it on the next page. So what it means that after dilution, the amount of or the yes, the mole in solution 1 is the same as the mole in solution 2. They do not change. It's the same thing. That's the first thing you need to remember. And it's very important for you to note. Now, let me just write something here. Now, how do you determine the mole of substances? For you to get the mole of substances, you only need to multiply the concentration by the volume. That's how you determine moles of substances. And remember, this is actually coming from the number of the concentration equals to mole over volume. I believe you remember this equation. So you just did a change of subject. You got mole equals to concentration times volume. That's all I did to get the mole equation. So it's important you remember this mole equation. And let me quickly clean that. Okay. Okay, so we have mole equals to the concentration times volume. Let's put it down. Now what it means is that for the first solution, which is N1, if you want to determine its mole, it will be the concentration of the first solution times the volume of the first solution. So let's put this one down. You can call it 1. And the second solution, N2, you can say that its mole will be the concentration of the second solution times the volume of the second solution. Let's write this down. Equation 2. So from these two, we can just come and substitute equation 1 and equation 2 into this equation. So we can say that because we know that N1 is equal to N2, we can actually say that C1 V1 is the same as C2 V2. This equation is even more important. And what this equation is saying is that the number or the amount of substance in a solution before dilution is the same as the amount of substance in a solution after dilution. That's what the equation is saying. The C1 is the concentration of the solution before the dilution, and the V1 is the volume of the solution before the dilution. After the dilution, you would have a new concentration, which is C2, and you also have a new volume, which is V2. So in most dilution calculations, this is the formula you are going to use. Remember that C1 times V1 is always equals to times V2. And the C2 is the concentration of the solution after dilution. The V2 is the new volume of the solution after dilution. While C1 is the concentration of the solution before the dilution took place. And V1 is the initial volume of the solution before it was diluted. We need to keep this in your head. And we are going to use this to solve some problems. And I believe we can start with example number 1. So in example number 1, we are being given this question, and the question is saying that a 5 centimeter cube of 0.1 molar sodium hydroxide solution was diluted with 2 cm cube of distilled water. Determine the molarity of sodium hydroxide after it has been diluted. So let's put down some important information. This one, maybe this one, Then we are asked to determine the molarity of the solution after it has been diluted. Now remember that molarity is another word for concentration. You need to remember that. Now let's look at the question again. The solution was initially this, and this solution was diluted, and after dilution you got the new solution, which is this one. So the first volume, the initial volume of the solution, what was it? Is the 5 cm cube, and the initial concentration of the solution was 0.1 molar. So let's put that one down. So what it means that C1, as the initial concentration of the solution, is 0.1 molar. Because of space, I will not bring the molar, but remember it's molar. Then the V1, that's the initial volume of the solution. It is 5 cm cube. I should have written 5 cm cube because the space isn't enough. I write just 5. Now let's go to the solution 2. In solution 2, what happened? So here too we need concentration of 2 and the volume of 2. But here, interestingly, we are rather asked to determine the molarity of the sodium hydroxide after it has been diluted. So you were asked to determine this. That is what you are looking for. But what it means that the volume 2 had been given to you. But let's see what actually happened. We are told in the question that it was diluted with 2 cm cube of water. So 2 cm cube of water was added to the initial solution. If 2 cm cube, if the initial solution had volume of 5 cm cube and additional water of 2 cm cube was added, what it means that the new volume of the solution will be what? It will be the 2 plus the 5. So that will give us 7 cm cube. So that is the new volume of our solution. Now we're going to now use this information to determine the new concentration of the solution that we gotten after it was diluted. So let's repeat these informations on another page, then we'll use them to solve that problem. So first, we're going to write our C1 is what? Our C1 we are told is 0.1 molar, V1 is equals to 5 cm cube. Our C2 we don't know, that's what we're going to look for. Our V2 we've determined that it is 7 cm cube. Now, so we are going to use the following information to determine the new concentration. And we know that from the formula we've learned earlier on, C1 V1 will be equals to C2 V2. This formula you should know, where C1 is the initial concentration, V1 is the initial volume, C2 is the final concentration, V2 final volume. So what are we looking for? We are looking for what? We're looking for C2. So what it means that we have to make C2 the subject. So if we want to make C2 the subject, we have to divide by V2. So we do the same thing to the left side of the equation. So this will cancel this. You are left with what? C2 equals to C1 V1 all over V2. Now with this, we can determine the concentration of the the new concentration of the solution. So let's do this. Now from the information provided that C1 is 0.1 times V1 is 5 centimeter cube divided by V2, which is 7 cm cube. Let me just clean the cm cube, it's not really important. So you now have this. When you do the mathematics, you are going to get what? You get 0.07 1 molar. That's the answer. So that's how you determine the concentration of the solution after it was diluted. That's it. Now, but you realize something in the calculation. I didn't convert the C2 to DMQ. In previous videos, I remember we said that anytime volume is given to you in chemistry and it is in CMQ, it appropriately convert it to DMQ. Yes, here in this case, the reason you do not need to do that is because at the end of the day, the CM cubes cancel out anyway. So if I had converted to DM cubes, it would have still cancelled out. So that's where it's not necessary for you to do the conversion. So usually in problems that involves dilution, you will not necessarily, and especially when you are dealing with this formula, you will not necessarily have to do the conversion from CMQ. CM just use it like that, and eventually the CM cubes would be cancelled out by themselves. And if your answer should even be in volume, you can always leave your answer in CM cube. So that's the what you need to remember. Now let's look at another example. In this example, being told that a 0.5 molar solution was diluted to get this solution of volume this. Determine the initial volume of the solution. So we have a solution. This solution was diluted and became this solution. So 1 and 2. Now, solution 1, the concentration was what? It was 0.1, sorry, 0.5 molar. But we are not told the volume of this solution. So we do not know the volume. Volume 1, we don't know. We are going to find that out. Now, but it was diluted to get 0.1 molar solution. So it was diluted to get a second solution with concentration of 0.1 molar. Alright? And whose volume is V2 is what? 800 cm cube. And we are asked to determine the initial volume, that is the V1. So let's put down the parameters. Then after putting down the parameters, we'll use our dilution formula to determine the volume 1 or the initial volume of the solution. So let's do that. So here C1 we are told is what? 0.5 molar. V1 you don't know, that's what we are going to look for. C2 we are told is 0.1 molar and V2 is 800 cm cube. But we know that the dilution formula states that C1 V1 is equals to what? C2 V2. So with this, we'll determine the V2. Yes, we are supposed to determine V1. Let me clean this. So to determine V1, what it means is that we have to make what the subject, V1 the subject. So we have to get rid of the C1. So divide through by C1. V1 will cancel out. So C1 is gone, C1 is gone. What it means is that our V1 is now equals to C2, V2 all over C1. That's what we're going to use. So our volume 1, that's the initial volume, will be equals to the concentration 1, that's the initial concentration, times, sorry, the final concentration times final volume divided by initial concentration. So that will give us what? C2 is 0.1 times V2 is 800 divided by C1, which is 0.5. And when you do the mathematics, you're going to get what? We're going to get 160 cm cube. So what it means that will be our final volume of the new volume. Sorry, the initial volume, the V1. So it was this initial volume that was diluted for us to get the new volume V2 800 cm cube. And remember, the question asked us to find what initial volume of the solution. That's the V1. So that's the initial volume of the solution. It is 160 cm cube. Let's look at another example. So in this example, we are being told that the solution of initial volume of this, so this is the initial volume of the solution, was diluted with this amount of water to obtain new molarity of this, new concentration of this, determine the initial concentration. So we are finding the initial concentration of the solution. So let's see if we can make sense of the question. So first, this was the solution. It was diluted and got another solution. So solution 1, solution 2. The concentration of the first solution, volume of the first solution, you don't know, we'll be putting that there very soon. Concentration of second solution, volume of second solution, we'll put that there soon. Now, but we are also told that it was diluted with 50 cm cube of water. So 50 cm cube of water was added to the first solution to get the second solution. So let's write that one down. Now, the initial solution, we are told it has volume, this one, of 100 cm cube, right? So let me write that one down. But we are not giving the concentration. We don't know the concentration yet. Now, the new solution, we are told, has concentration of what? 5 cm cube. Sorry, 5 molar. So let's put that one down. Okay. Now, there's another interesting thing happening here. The initial volume of the solution was 100 cm cube, and it was diluted by water or distilled water of 50 cm cube. So what will be the new volume? So remember, initially the volume of the solution was 100 cm cube. Then we came added 50 cm cube of distilled water to this solution. What it means that the new volume of the solution, which is V2, 150 cm cube. That's the V2. So these are the informations we're going to use to solve the problem. C2 we don't know, that's the initial concentration, and that's what we're going to look for. V1 we are told is 100 cm cube. C2 we are told is 5 molar. Then V2 we know is now 150 cm cube. And we got that by adding the quantity of water, which is 50 cm cube, to the initial volume of water, which is 100 cm cube. So let's put down our information, then we use that to solve the problem. So we have C1, V1, C2, V2. C1 we don't know, C2, V2, V1 sorry is 100 cm cube. Then C2 is what? Is 5 molar, and V2 is 150 cm cube. So that's what we're going to use. So let's put down our formula. It's C1V1 equals to C2V2. So that's what we're going to use. Now we are told that we should find the C1. So we'll make C1 the subject, meaning that we'll get rid of the V1, get rid of V1. So this V1 will cancel out V1. You are left with what? You are left with C1. That's what you are looking for, which is equals to C2 V2 V1. Just remember that. So that's what we're going to use. So concentration as the initial concentration, which is C1, is now equals to the C2V2. We know C2 is 5 molar times V2, which is 150 molar, sorry, cm cube, divided by our V1. Our V1 we know is 100 cm cube. So when you do the maths, what are you going to get? So 5 times 150 divided by 100, that will give you 7.5 molar. So that should be the answer to this problem. So the initial concentration of the solution before it was diluted, 7.5 molar. Now look at the final example, then we'll bring the episode to an end. So in this example, we are told that 0.6 molar of this volume solution of NaCl was diluted to obtain a solution of 0.2 molar. Determine how much distilled water was added to the original solution to obtain its new concentration. So you are having a solution. This was diluted to get this new solution. So solution 1, solution 2. Then what happened? The concentration of the first solution, volume of the first solution, you don't know. Concentration of the second solution, volume of the second solution, we don't know yet. But here, the concentration of the first solution is what? 0.6 molar. Its volume was 200 cm3. Now, it was diluted, and after the dilution process, its new concentration was this one. So it was 0.2 molar. We do not know the final volume, so let's make it question mark. That's what you're going to look out for. So let's put down these parameters. And once we put them down, we'll be using them to look for the new volume. So let's do that quickly. So C1, V1, C2, V2. C1 is what? C1 is 0.6 molar. V1 is 200 cm3. C2 is 0.2 molar. V2 we don't know. But we also know that the dilution formula is C1 V1 equals to C2 V2. So put down that one. What are we looking for? We are looking for V2. So we divide by C2 to make V2 the subject. Divide by C2. So when you do that, you get rid of the C2 here. So we are left with what? V2. That's what we are looking for. That will give us C2 V1. Sorry, that will give us C1 V1 all over C2. So that's what we're going to use. So now we just substitute at this point. So C1 is what? 0.6 times V1 of what? 200 divided by C2 of 0.2. So when you solve for this mass, what are you going to get? 0.6 times 200 times 0 divided by 0.2. That will give us 600 cm cube. Now, so this 600 cm cube is the new volume. That's 600 cm cube. But let's go back to the question and let's look at what the question is actually asking us to find. Now look at what the question is asking us to find. It's asking us to determine how much distilled water was added to obtain the original solution. It did not ask for the new volume. It asks how much distilled water was added to the original volume to get the new volume. So that's what the question is asking us. So that means that we've not answered the question yet. Now this is the new volume. This was the original volume. So the question is how much of water or distilled water was added to volume 1, which is 200 cm3, to obtain the volume 2, which is 600 cm3. All you do is to subtract the V1 from the V2. When you do that, you get what? 400 cm3. Remember 400 cm3, you got that by subtracting the V1 from the V2. V1 is 200 cm3. V2 is 600 cm3. 600 minus 200 will give us this value. So this is the amount of distilled water that was added to the initial volume of the solution to obtain the new volume of the solution. So that will be the answer for this problem. I believe this will bring us to the end of today's lesson. Please subscribe to the channel if you've not done that. Also, share the video with your friends who might be struggling in integrated science. We'll meet again in the next episode. See you and take good care of yourselves.